All right, so this reference chart talks about the three forms. We have talked about these two forms, vertex and standard, previously in the other parts. And we're going to look quickly at factored forms. So we've talked about how to factor a trinomial, but we also have what we call factored form of a quadratic, which just means that it's factored out. So when we did vertex form, we talked about the key features here where the x-axis is the h value, or the axis symmetry is the h value, the vertex is the h and the k. So the y-intercept, if we ever need to find the y-intercept from vertex form, you're just going to substitute 0 in for x and solve. So you just put 0 in here and you solve for the y value. And then for the x-intercepts, those are the solutions. So you set this equal to 0, and technically you would solve that most likely by using the square root method. We'll get to that a little bit later when we talk about solving in the next unit. So standard form, again, axis symmetry, we've talked about x equals negative b over 2a. Once we have that negative b over 2a, then we substitute that in and get the y value. The y-intercept is the c, and then we will also talk about how to find the x-intercepts using factoring square roots or the quadratic formula. Again, we will get to that in our next lesson. So then we have factored form. So our a value is still going to be in front, but we have the factored pieces with nothing being added or subtracted to it. So the axis symmetry, so you see how it says p and q. So we're going to take the p value plus the q value, and we're going to divide that by 2, and that's going to give us the axis symmetry. And then just like with the standard form, when we find that, we're going to substitute that into the original problem for x, and we're going to find the y value. Now the y-intercept, we're going to substitute x in or substitute 0 in here, and then solve for y. And then again, we're actually going to talk about the factors this time, just because in factored form, the factors can actually help us find the zeros. Now, one thing I will say is if you notice that this p right here is when it's in the standard form, that's minus p and minus q. But when we actually use it to find the axis of symmetry, we do the opposite value just like we did with the h previously. So we're just going to look at a few examples and kind of go from there. Now, the main reason you want to look at factored form, yes, my a value here is a negative 2. And it can tell us that it's opening upward or downward. So this one is negative, so it's going to open downward, which means I'm going to have a maximum value. Now, when it's in factored form, we can always multiply this out and put it in any form I want to. So like I can multiply it out and put it back into standard form. I can take standard form and then convert it into vertex form by completing the square. So each form kind of tells us a little bit of something different. But if I want to find my axis of symmetry, so remember my axis of symmetry formula is x equals p plus q divided by 2. So in this one, my p value is 6 and my q value is negative 3. So we're going to say x equals 6 plus negative 3 and divide that by 2. So my axis of symmetry is located at 3 over 2 or 1.5. If I want to find the whole vertex, I now know that my vertex has an x value of 3 over 2, and I've got to substitute into the original problem to find the y. So I can substitute that in. So we're going to say 3 over 2 minus 6, and then 3 over 2 plus 3. All right, so I can see that once I substitute that in, I'm going to get negative 40.5. So you can see that that is 40.5. I can verify that using my actual equation. So we have x minus 6 and then x plus 3. And I can see that my vertex is located at positive 1.5 and 40.5. The main thing that the vertex form is going to tell us is the solutions are the x-intercepts. The reason that that's going to work is when we get to solutions, we can take the factors of any quadratic and set them equal to 0 and find the solutions. And again, we're going to go into more detail about that later. But if I want to find the x-intercepts, all I do is I take my two factors. So my two factors are x minus 6 and x plus 3. I don't worry about the 2 because that doesn't have an x. And I set that equal to 0 and I solve it. So I'm going to add 6 over. And I have an x-intercept at 6, which is located at 6, 0. And then I have x plus 3 is equal to 0. So we're going to subtract the 3, and then that's going to give me an x-intercept at negative 3. So I have another x-intercept located at negative 3 and 0. So again, all of these forms can tell us different things, and they can help us kind of analyze where our key features are. And some give me key features easier than others, or certain key features. Looking at number 2, I have an a value of 1, so I know that this one is going to open upwards. Now, if I want to find my axis of symmetry, so remember the axis of symmetry formula that we just got done talking about is x equals p plus q divided by 2. But this one's a little bit different because I have a 3 in front right here. So if I were to rewrite this, remember we were factoring, we did that bottoms up where we move it up. So this is technically x plus 4 over 3. And that's important because we have to, when we do that p value, it has to be when x is by itself. So I can now say that my p is equal to negative 4 over 3 and my q is equal to positive 5. So I have x equals negative 4 over 3 plus 5, and we're going to divide that by 2. All right, so I have, I'll make sure I get this typed in correctly. So negative 4 over 3 plus 5, and that's going to be divided by 2. And that's going to be 11 over 6, or about 1.8. So my axis of symmetry is at 11 over 6. Now, if you remember the vertex, we already know the x value because that's the axis of symmetry. So we would just plug in 11 over 6 into our problem. So we would say 3 times 11 or excuse me, let me take that and put it in the parentheses. So 3 times 11 over 6 plus 4, and then 11 over 6 minus 5. So we have plus 4, and then we have, so 3 times that, and then we have 11 over 6, and that's going to be minus 5. So again, we get negative 30.08 or negative 361 over 12. So I know these kind of came out to be weird numbers, and that's okay. I mean, that's still where it's located. Okay, so if I check this out and I look at the vertex and I put the original problem into Desmos, so I have y equals 3x plus 4 and then x minus 5. Okay, so I have my vertex here. It is opening upward. And remember, we calculated these earlier. We put them in decimal format, and those do match the vertex itself. We just put them in fraction format. All right, so again, when we talk about our factored form, we really like to use the factored form to find our x-intercepts, where they cross the x-axis. So we're going to take the two factors, and we're going to set those two factors equal to 0 and solve them. So I'm going to take 3x plus 4 equals 0. So we're going to subtract 4. And then I have 3x equals negative 3 or negative 4, and then divide that by 3. So we should have an x-intercept at negative 4 over 3. Okay, and then I have x minus 5. And I'm going to add 5. and then we have x equals positive 5. So if I were to write these as actual points, we would say negative 4 over 3 and 0. And this one would be 5 and 0. So I can look at that. I can see across the x-axis that negative 1.3. So negative 4 over 3, that's where that comes from. And then it's crossing at positive 5. So again, factored form, I can multiply it out and put it into any form I want, but factored form really does help us find the x-intercepts because it's already in factored form, which you'll find later that to find those x-intercepts, those solutions, we would need to factor it and put it in factored form. All right, so for this video, we're going to be talking about writing quadratic equations in factored form. So we're really going to talk about a bunch of different scenarios and what factored form is. So factored form means that we're able to identify the factors of a quadratic just by the factor and what the number is itself. So the factored form is a, and then we're going to have x minus m times x minus n. Now, what you need to understand is that when we look at these, we have the a value. Now, my a value is still going to represent the general shape. So when I say the general shape, the a value is going to tell me, and the a talks about whether it's going to open up or open down. So remember, if a is positive, it's going to open up. If a is negative, it's going to open down. So a still describes the general shape, and the a is also going to tell me whether or not it is going to be it's going to be skinny or is it going to stretch, that kind of information. So that a value, if it's greater than 1, then it's going to be a vertical stretch. If the a value is less than 1, then it's a vertical shrink. All right, so the new pieces of information that we're going to look at is the m and the n. So the m and the n are going to represent the factors. So those factors they can be called solutions. They can also be called the x-intercepts. They can be called the roots, or they can be called the zeros. These are all meaning the same thing. So if any of these words mean the same thing, but ultimately graphically it means the x-intercepts. Okay, and they're called the zeros because that's where it crosses the x-axis, where the y value is 0. So what we're going to be looking at is we're going to be looking at writing a quadratic in factored form if I give you a point and the solution. So a point on the quadratic and the x-intercepts basically. So how would we go about doing that? Well, the first thing you're going to do is you're going to write the factored form formula. Now, that factored form formula is that a times x minus m times x minus n. Okay, so based off the information, you're going to substitute that information in. Okay, so then at that point, you're going to identify or you're going to label all your parts. You really need to make sure you know what pieces go together. So you need to know what is the vertex, what is the point, or what's the solutions, the x-intercepts. You need to know what is the point that is actually going through. Now, once you are able to label all the parts, then you're going to substitute those values into my factored form formula. So remember, substitute means that you're going to then after you substitute all of the parts, that's when you're going to solve for a. Because the whole thing is here is that's what we'll be missing, is we're going to be missing the a. Now, after we solve for a, that means that we're going to substitute everything back into the formula except for the x and y from the original point that was given. So we're going to work through this problem right here, and we're going to look at each step, and I'm going to kind of color code to walk you through it. So we're going to write the factor form formula. So again, the factor form formula is a equals x minus m times x minus n. Now, the next thing we need to do is we need to label our parts here. So we want to label the information that is given. Okay, so it says that the parabola passes through the point 6, negative 2. So 6, negative 2, that's my x and that's my y. It also tells me that my solutions are 4, 0, and 8, 0. So my solutions mean that these are my M and my N because of the fact that it says solutions. Those are my x-intercepts. Okay. Now we're going to take that information and we're going to substitute that into the problem. So if we substitute that into the problem, we're going to have all of those pieces together, and we're going to have, whoops. So, sorry about that. So my y value is going to be -2. We do not know my a value. We have an x value. So my x value is 6 minus my m. My m is 4. Then we have a 6 again for the x minus my n value. And at that point, we're going to solve and simplify. So we have -2 equals a. 6 minus 4, that's also going to be 2. And then we have 6 minus 8, which is going to be -2. So I have -2, and then 2 times -2 is going to be -4a. And I'm going to just put it in front as a coefficient. And I'm going to finish solving, and I'm going to divide by -4 to get what the a value is. So my a value is equal to +1/2. Now, I know my a value, so all I have to do at this point is to substitute. So at this point, I did solve for a here, and I started solving for a at this step right here. Okay, so once I have my a value, I can plug everything back in to my original format. So I know my a is 1/2, and so I have x minus my original 4, and then I have x minus my 8. And the reason it's minus is because that is the original formula. Now, if I have a number that's negative and I substitute, that's when it'll change into a positive. All right, the other thing that we need to look at is let's look at it graphically. So if I'm looking at Desmos and I put in my form or quadratic that I found, so I have 1/2, I have x minus 4, x minus 8. All right, so it told us that we have, in this problem, we have those original solutions at 4 and 8. So I can see those x-intercepts, they are in fact crossing at 4 and 8. And it told us that the original point that was in the problem was 6 and -2. So if I look for 6, -2, I can see that that point is on the graph. So we are in fact correct here. All right, so with that being said, we should now be able to look back, and we should be able to see that we were able to substitute the given information. And once we substituted in that given information, that information provided us with an a value to complete the factored form. Now remember, factored form of a quadratic is when I have my x-intercepts already in that x minus m, x minus n, and the a value out front if there is an a value. Okay. Now, as a review, if we're converting factored form to standard form, okay, so remember standard form is ax squared plus bx plus c. So let me remind you again, standard form is ax squared plus bx plus c. Now, in order to do that, we're going to do something very similar that we did when we had vertex form and we went to standard form. So we're going to multiply, and we're going to multiply the binomials. Those are the factors that are in the parentheses. So when we go to multiply the binomials, we are multiplying these pieces together here. So we're going to start with these two, and we're going to multiply those together. Now, you can either use the full method, just because it is a binomial, or you can use the box method that we talked about previously. I'm going to go ahead and use the box method, but just as a habit of what I use in my other classes. So we're going to take the two parentheses and we're going to multiply those pieces together. So I have x and -3, and then I have x and 7. So if we multiply x and x, that gives me x squared. X times 7 is going to be 7x. X times negative 3 is negative 3x. And then negative 3 times 7 is going to be negative 21. So that now gives me y equals 2. And then we're going to combine those like terms there. So that's going to be 7x and negative 3x is 4x minus 21. Okay. So once we do that, again, we said combine like terms. So we combine any of the like terms that we have together. All right, and just to kind of keep with our color coding, I'm going to use the box method, which is what I did here. All right, so once we were able to combine our like terms, we're now going to do the final step, which is to distribute the a value. So the a value in our problem is a 2. So we're going to distribute that 2 into the rest of the polynomial that we have created here. So we're going to distribute the 2 to the x squared, the 2 to the 4x, and the 2 to the negative 21. So that's going to give me a final answer of 2x squared plus 8x minus 42. So we've taken this factored form and we've converted it into standard form. So we're going to do some more examples here, and we're going to be looking at, they're giving us the solutions and they're giving us a point, and they want us to write it in factored form. So we're going to do what we did before. Now, when they write solutions like this, you see how it's put in set notation? That set notation does not mean an actual point. That means that it's the two solutions, which would be 0, or sorry, not 0. It would be negative 3 and 0 as a point, and it would be 1 and 0 as a point. So just keep in mind when they list solutions like that in those set notations, they're just listing the numbers of where it crosses the x-axis. So what we're going to do is just like we did before, we're going to use our factored form. So we have x minus m times x minus n. So I'm going to identify my information here. So remember, this is going to be an m and an n because they've listed these solutions, okay? And then my point is going to be my x and my y. So we're going to substitute that in. So I'm going to substitute in negative 3 and negative 3m for y. We don't know the a. We know the x value is negative 5, and we're going to subtract the m. Now remember, the m is a negative 3. We're going to also substitute the x value again, and we're going to subtract the n, which is 1. Now, we need to simplify this, and we need to solve for a. So if we simplify this, then I need to say negative 5 minus negative 3, so that's technically going to be negative 2. And then we have negative 5 minus 1 is going to be negative 6. All right, so we're going to keep solving for a here. So we have negative 2 times negative 6. That's going to be positive 12. So we have 12a. And then we're going to divide by 12. Now, when we simplify this, we should get that a is negative 1/4. So at this point, we're going to finalize our answer by plugging everything back in. So we have our a value is negative 1/4. Now remember, we don't substitute the x and the y this time. We're just substituting the information to write it. So the original m was a negative 3. Now if I have minus a negative 3, that's going to convert in just a second, and I'll show you how. And then we have x, and our n is a negative 1, or positive 1, so we're going to subtract that. Now, what happens when we have minus a negative? That's going to turn into x plus 3. So just keep that in mind. The opposite sign when you substitute, it's going to look like the opposite sign when you substitute it in, because the original formula is in fact a subtraction sign. Okay. All right, so let's look at the next example. Same situation. We have our solutions are at 0 and 6. So again, that means that I have a solution at 0 and I have a solution at 6, 0. So the actual points are those, but these are your M and your N. This is your X and your Y that goes to that point. All right, so if we start with our original format of A times X minus M times X minus N, we're going to substitute what we have in this problem. So my Y value is going to be -9. We do not know the A value, which is what we're trying to find. The X is -3 minus M is 0. Then we have another X of -3 minus 6. And then we're going to simplify. So we have -3 minus 0 is still going to be -3. And then we have -3 minus 6, that's going to be -9. So if we multiply that together, we have A equals 27. And again, you can write it like that or you can put it in front. But we are going to divide here. And we should get an A value. And my A value is going to be -1/3. So now I just finalize by putting everything back into the original problem. So I have -1/3 for A. All right, then I have X. My original M was 0. So I can write -0, but I definitely am going to want to simplify that later. Then I have my 6, so X minus 6. Now that -0 is not necessary. So we're going to say -1/3 X. And then times X minus 6. All right, so this last example, obviously it's formatted where they actually give you the solutions. Again, they could format it where they did the set notation and just list what the solutions are or the x-intercepts. All right, so we have Y equals A times X minus M, and then we have X minus N. All right, so we know that this is my X and my Y. We'll call this M and this one N. So we're going to substitute those values in. We're going to say that the Y is 9. We're solving for A. My X is -2, and this is minus -5. My X is -2 again, minus my N, which is -3. And then we need to simplify. So I have 9 equals A. So -2 minus -5 is going to wind up being +3. And then -2 minus -3 is going to wind up being a +1. So 9 equals 3A. Divide by 3. And we get the A value is +3. So at that point, we put it all back together. So my A is 3. My X, original M, was -5. So at this point, if you kind of gotten the pattern, you don't necessarily have to write it as minus a -5. You can just go ahead and put X plus 5. And my other original was -3, so we can put it in as the opposite. Now let's kind of go back to Desmos and let's look at some of this information. So we have Y equals 3. We have X plus 5 and X plus 3. And I forgot the 3 value. So we can see that they did cross that -5 and -3, given the fact that they gave us the intercepts. And they told me that the point of that was on the graph was -2 and 9. And again, I can see that that is a point on the quadratic. So any of these, and my A value was positive, and it is opening upward. So if I go back to this one, we got -1/3 times X and it was X minus 6. Okay, so we can see that it's opening downward. It also told us that, so my x-intercepts are at 0 and 6, which is true. And it was going through the point -3, -9. So I put a -3, negative 9. I can, in fact, see that point is on the quadratic. And again, if I wanted to take this quadratic and I wanted to turn this into standard form, all I would have to do is multiply this together. All right, so if I'm able to get it in factored form and I want to convert it to standard form, all I would do is multiply my binomials together and then distribute. So we would say the x plus 5, and then we would do x plus 3. So we have x and 5, x and 3. So that would be x squared. That would be 3x, 5x, and 15. Okay, so we would have y equals 3 times x squared plus 8x plus 15. And then at that point, all we would have to do is distribute the 3. So if we distribute the 3, that would be 3x squared plus 24x plus 45. So you can convert between any form that you like depending on which one's given or which one you're looking for. Now, so if I have some tables, so if I have a table, remember there's 3 things that we need in order to write my factored form. So we need 2 of the x-intercepts, okay? So we need 2 x-intercepts and we need 1 point. So when I look at a table, an x-intercept is always going to have a y value that is 0. So y value of 0, okay? So when I look at my table, I can see that I have a y value 0 here. And I have a y value of 0 here. So that means that negative 2 is the intercept and 3 is an intercept. So that's going to be my m and my n. So I can say that I have negative 2, 0, and I have 3, 0. Now, we also need a point. It really doesn't matter which point you choose. Pick any point. Pick any point. So I'm going to go with, let's say, 0 and negative 6. Or excuse me, 1 and negative 6. All right, so if I choose 1 and negative 6, that means that's going to be my x and that's going to be my y. And we're going to do what we've been doing. We're going to substitute it into the formula. So my x value is going to be negative 6. Okay. And that's going to equal the a because we don't know the a. My y value is negative 6. My x value is going to be 1 minus my m. We identified that as negative 2. And then 1 minus my n, which is 3. And then we're going to solve. So negative 6 equals a times 3 and negative 2. All right, so when I look at this, I have negative 6 equals a times negative 6. And of course, if I divide that, that's going to equal a positive 1. So I can finalize my quadratic that I would have found in factored form. So I can write the 1 in front, but it's not necessary. But I would say x plus 2, x minus 3. So that 1 in front, again, is not necessary. I would just write my 2 factors. All right, same rules apply if I have a graph. All right, so we have our x-intercepts, and our x-intercepts are at negative 7 and 0. And at negative 3 and 0. Now, when we go to pick a point, we want to make sure that we're using a perfect point. Now, if I look closely, so my first instinct, oh, well, here's a perfect point. And it looks pretty close, but if you notice, it's off just a tad bit on that problem. So we always want to make sure we pick a perfect point. I do have some perfect points already identified, that perfect point is going to be at -1 and 9. Okay, so we have -1 and 9 there. So we're going to substitute in what we know. So this is my x and this is my y. So we know that we have a y value of 9. That equals a. And then we have an x value of -1 minus -7, which is my m. So again, just to be clear, this is my m, this is my n, because those are where it crosses the x-axis. And then we have -1 minus -3. And if you've gotten the pattern where you can just realize that the negative is going to be plus, then do that. So I'm going to simplify here. So a is going to be a times 6 and then times 2. So I have 12a once I simplify, and 9 and 12 are both divisible by 3. So we have a equals 3/4. So if I put everything back together, I have 3/4 times x plus 7 and then x plus 3. So equations, obviously, or if they're given to us, we can put the pieces together. If I have my graph or my table, I can still identify those pieces. All right, so we have the standard form. If I'm converting this to standard form, remember we're converting this to ax squared plus bx plus c. All right, so we're going to start by multiplying our binomials together. So when we multiply those binomials together, we're going to be multiplying the x and the -4 and then the x and the -2. All right, so that's going to give us x squared, -4x, -2x, and +8. So we're going to combine those like terms. So we have a -2x and a -4x. So that's going to make x squared minus 6x plus 8. But we need to distribute that -1/2 into my problem. So we're going to distribute the -1/2, and we're going to distribute it to every term into the parentheses to turn this back into standard form. So this is going to be -1/2 x squared. So half of 6 is 3, but a negative and a negative is going to make +3x. Half of 8 is 4, but that's going to turn that into a -4. All right, if you have any questions, please let me know, and I'll be more than happy to help.